Next set of homework problems for section 1.4, numbers 11 through 30, have to do with solving one-step equations. And we're going to ask you in Math 60 to do a particular method for doing this. So first, let's talk about what it means to solve an equation. We talked in the last video about what a solution to an equation is. Well, solving an equation means to find the solution, to find the value or values of the variable that make the equation a true statement. So remember, a solution was the value that makes it a true statement. Solving is the process of finding that value. So the important thing here for me is this underlined part here that says the equation is solved when it's in the form x equals some number. So if we're trying to solve this equation here, whatever happens in between, this blah, blah, blah part, we know we're at a solution when we have something that looks like this at the bottom. So when we have x on one side, a number on the other, we know we've solved it. So when we solve equations, what we're going to ask you to do in Math 60 is be really explicit about figuring out what's being done to the variable, and then how can we undo that and get the variable by itself. And the way we undo it is do the opposite operation. So the opposite operation for addition is subtraction, which means the opposite of subtraction is addition. And then multiplication and division are opposite operations. And whatever opposite operation you do it to both sides of the equation. And I want to show you why that is so that it's not just mysterious to you. If we have a true equation, so here's a nice simple equation, 2 plus 3 equals 5. So if we were to subtract 3 from one side of the equation, then we'd end up with this, and that's obviously not true. So that's not an equation anymore, and that means that we can't do that. We can't subtract 3 from one side of the equation. However, if we were to subtract 3 from both sides of the equation, so if I do 2 plus 3 and then subtract 3, I'm back at 2, and then 5 minus 3 gives me 2, and now I have a different equation, but it's true. So that means that that method of subtracting 3 from both sides of the equation worked. So we're going to do the same thing when we're working with equations that have variables in them. So we're going to look at what's being done and then figure out what to do to undo it. And what we're going to do to undo it is do the opposite operation to both sides of the equation. So we're going to ask you to use this quick little table here, this do, undone, do, done, undo table. And for this equation, it's really simple. What's being done to the variable x? We're subtracting 17. And so to undo it, we do the opposite operation. And so that means to undo, we're going to add 17. And whatever we do to one side of the equation, we're going to do to the other side also. So I'm going to do plus 17, plus 17, and then I'm going to write a new equation. These 17s cancel out, and I have x equals 26. So that's my solution because it looks like a solved equation. It's x equals some number. So I'm saying that the solution to that equation is 26. And the way to check it is write the original equation down, and then just check it like we did in the first video for this section. We check it by plugging the 26 in and seeing if this is true. Is that a true statement? It is a true statement, so that means that we're correct and that the solution to the equation x minus 17 equals 9 is x equals 26. So pay attention to this do or done undo table over here because we want you to get used to using that. Helps you keep from getting confused while you're solving an equation. Okay, let's do a quick one. Another one here. what's being done and what do we do to undo it. What's being done to m right here is it's being multiplied by 7. So I'm just going to write that in shorthand like this. And so then to undo it, I'm going to divide by 7. So I'm going to go back over to my equation over here and divide by 7. I'm going to divide both sides by 7. I end up with m equals 9. So then I'm going to check it by writing my original equation, putting 9 in there, and asking if that's true. That is true, and so we know that our solution is correct. M equals 9 as the solution. Here's one with division. So this means y divided by 5 equals 21. So what's being done to the variable is we're dividing by 5. And so to undo it, we're going to multiply by 5. Whatever we do on one side, we're going to do on both sides of the equation. So it's like this. These two 5's cancel out, and I wind up with y equals 105. So then I'm going to go down and check my equation. So my original equation was y over 5 equals 21. So I'm going to plug in my proposed solution and ask, is that true? It is true, so we know that our proposed solution is correct. Y equals 105.